People, and without further ado, I had to, even though I know it's late, I know I had to come in here and bring y'all some good news about this build. So, y'all probably saw the last two live streams I tried to do started off with total failures of this print, right? Which is me trying to just get this TPU back in the system and back in the loop again, after having the machine used to just printing ABS. For whatever reason, it just wasn't filling the TPU. So I had multiple clogs. I found out that the buffer plastic for the spring in the extruder had melted, and so the part that was putting tension on the spring so that the filament could get grabbed by the gears, that spring was not applying pressure anymore. So with me printing with a harder material, I didn't know that that had happened with the spring or whatever. But the moment I went to something softer, I end up getting those jams, like back to back jams, and then I just kept having to take the extruder off. I couldn't figure out for a little bit exactly what was going on, but then I noticed, I got to a point where I'm like taking everything off of the extruder now. And so I get ready to unloosen the screw that puts the tension, that puts the pressure on the spring. And I noticed that the plastics inside of the spring is not even on the end of the spring anymore. So, long story short, that part was printed in PLA, right? Well, PLA has a lower melting point um, than ABS. So if you're printing in ABS, in which I was doing a lot of, sitting up at 260 degrees right at the extruder, that those PLA parts are going to start melting. And so that's what happened. Um, and that was causing my issue. And after I got that set and situated, I had to go through a process to clean the nozzle out and get burn all that stuff that was just blocking the a nice flow inside of the nozzle. So once I got that, man, here we are. We sitting right. Man, I probably lost a lot of views. Uh I could have had a lot of people, you know, inside of the view. But it is what it is. We here right now. And we printing, as y'all see. I got a little bit going on, and my goal here was to not print this with um with the supports. I knew I wanted to have a clean back. I wanted this tire to look really nice, but I did not want to print with the supports. The first couple tries, I tried with the supports, and at some point I got to thinking maybe trying to print supports is going to be more of a risk than just taking my chances with printing the wheel for what it is. There's a small area where it makes contact with the bed, and then the rest of it is it's to where it has to be. And so you can see, if you see under here, how big of a lip we have, right? You can see that overhang is crazy. But with PL or with TPU, you can get away with this. TPU is such a sticky, it's such a sticky filament that once it comes in contact with another part of the layer, it's going to do what it's going to do. It's going to stick. It's not going to give you a hard time as far as having a nice little bridge, especially if the bridge is like it's solid, which we have right there. It's a solid piece. So I'm satisfied with how it's looking right now, but man, it took me like a day and a half to get to this point. And this is kind of like what I've been going through when I'm doing this. But here we are, and we making it happen. So, um, what I had my goal was yesterday was to get this started and have this plan for you all while we design what would be our next our housing for our batteries, right? I wanted to completely design something different, like some plug and play type stuff, you know. I want it to be elegant, you know, I want it to look good, you feel me? And I don't want it to take too long to print. So I came up with a few ideas. I didn't take any measurements. I kind of wanted to just be on camera taking measurements and, you know, for some people to get in here and we chop it up and do it like we always do. But success on these wheels, they doing their thing. The numbers on the top of the screen is wrong. You know, it's not gonna take 6 hours. We've been printing. I've been printing for maybe an hour now, and you know, which is not bad because if you add up all of the four pieces there into one, that technically we would have printed one wheel within the hour. So we'll probably get done with this in like the next 4 hours. And while we do that, we're gonna get to that battery case. So let me grab my battery and I will take a look. And we'll set the pretty thing up there too, just for the people that just want to look at it and just look at how pretty it is. We'll set that up there for y'all. All right, so this right here is really a one of a kind. Um, I love the high discharge rating on these batteries, and I love the price I paid for these batteries. So both of those were really the reason why I stuck with this idea, because if I can always get these batteries at such a cheap discount, why not make my power supply out of these? But instead of having them to be so hard to get out, like this case locks these in like really good. Like all of this gets locked in good, right? Like you can't really just grab them and pull them out. Like you gotta take something and wedge it in there and pop it through the lips, and you know you have to do that for each battery. Now considering I want these to be a quick release battery supply where maybe we got a cap, we unscrew a cap or something like that, and then we can pour out the four batteries. That's pretty much the direction that I want to go in. And then we got to tidy this up because this is kind of long for what we got going on now. Okay, since we got our cord in the back here already where the housing is, we're gonna think of a way to make this look real nice and professional. So we got to do the same here. I just didn't know how far I was gonna have to take this, which is why I made it this long. And, you know, in the beginning, this would have been up in the front up here, and so this would have had to stretch all the way to the front like this. But now that we are beyond that point, now we have it in the central location. We don't need these extras out here. We can just bring it back to like this, or on this side here, have it loop back like this and something like that, you know. But we'll see what happens and where we'll go with this. But the first things first is I know that there's a lot of designs out there that people have on Thingiverse and all of those other sites. I could always go with one of their products, but the thing with designing something that's mine and that has my name on it, everything must be pretty much made by me, unless it is a um like these aluminum parts or whatever, which you know those are another thing by themselves. But that would be something I probably look into as well further down the line, is finding a way to like partner with some of these companies that make these parts and see if we can strike a deal somewhere. And something going on with this thing up here. It's like it doesn't wanna maybe acting up on some other stuff, man. We can never get that video camera to act right long enough, like that information to populate and all that. It's like, man, you get it and then it just acts up. So I think though what I need to do is switch the name of this. So we're gonna put battery pack. All right. Maybe that'll get some heads turning. We had to change the title of this video. And it is kind of late. I think I messed up the algorithms by trying to go live twice today and failing twice to do it, and I ended the lives kind of short. So now it's not trying to kick me out there. But we'll see if we can spark some interest. So what I'm gonna do is I'm gonna measure these batteries out. We're gonna get some good measurements. Um, we can actually take them over to CAD. We can take them over to Fusion and see where we go from there. Let's see, I got this piece here. I got parts all over here on the side and sometimes this desk gets so messy on me. And that's what happens when you got a lot of thinking going on. So let's do this. I'm gonna bring up the screen because we gotta make the screen pop, like Ciabatta say. So we gotta get in here. See how it's going. All right. So let's see. We can go over the fusion with some overhead going on right there. Let's go up in here and do what it do. Let's cut this part back. All right, so we got a little bit of video up there. For those that want to see this, still making progress. And then in Fusion, we're going to come over here and we want to start a new project. So, as I said before, we do need to get to a point where this thing is complete, you know. We got to get to a point where it's complete. Let's do that camera too for the overhead. So y'all can see me working. Let's unlock it and let's bring it out. Okay. All right, so and let's boost this up a little bit too. Let's beef her up. Now we want we want to get this battery thing starting. So I got these aftermarket parts already, which are fantastic if you're going to put this inside of something and leave it. But for what I'm doing, I didn't want to use those cables on this where you have to charge each individual cell at the same time while you're charging the whole thing, and buy a charger for that, which these chargers are expensive unless I go the route of creating my own. And I just didn't want to get too far into that. I wanted to just make sure that I have a smooth transition. I want this to be as smooth as possible. And so that requires, no thoughts, no thinking. I could just have one thing going on at the end that locks the batteries into play. And then the other side would be this adapter piece or the plug piece, whatever. However I'm gonna do it. So I haven't looked at any other ideas out there. I just feel like I want it to be fresh. I want it to be fresh. So I'll take some tape. This is for the sake of not charging my or not crossing my polarities as I do some measuring. I don't want to do no crossing, so I put the tape on the end So we're not creating no sparks, we're not creating no heat, none of that. All right, so the first things first is the actual battery size, right? Let me make sure we at 0. Make sure. So the battery thickness is a 0.2, pretty much 0.19. So I would say 0.2. And these are gonna, what the thing is about batteries, some of them swell. So it's good to have a few of them where you can kind of take a reference. So we'll say 2, right? So I keep that in mind, that what that width is. Now I want to give this some meat so that it just slides through there real nice and glides, right? And then I don't want it to be rattly either. So what I'm gonna do is I'm gonna create my first circle at 0.73. So 0.73 is what we're gonna end up with right here, right? First we gotta get us we gotta take one of these projects and turn it into a view only. So we got that complete. So we don't need him out anymore. We got him complete. We don't need him out anymore either. And we're narrowing it down. That we still gotta print out. This is for another day here. That 67 Impala rebuild. This is probably gonna end up on the chassis. Right now it's the Monte Carlo, but my next project, we looking for another Impala. So maybe the 67. I'm really liking the body of the 67. So I mean, you guys will get to see me landscape that in here as well. You just gotta stay tuned. You gotta stay tuned. All right, so we said 0.73. So first let's save this first. We're gonna call this the battery pack. Right? And name it the battery pack. Because we moving on. If you just got in here, I'm working on a battery pack now for this thing, rather than using this old thing that I put together, which it worked well, but now we just got to make this thing sleek, and make it to where the batteries can come out of this way easier than prying each battery out whenever I want to charge. So we're not stealing no designs. We're just gonna create this from scratch. We're gonna do it the right way. It's gonna be a nice way. It's all gonna fit in this thing real nice, and you'll see. So the first thing I did was I measured the thickness of the battery, and then now we're about to just go in here and map it up. So we settling in at 0.73 for the thickness. That'll be of the wall of just one side, but we gotta double these in sides, so they're gonna be side by side. But we have to get them down the middle first. So I think what I'll do is I'll complete one side and then I'll double it over, and then that second side will be how we get the case going, and it'll be like a real cool shape or whatever. We'll think of some cool stuff to do to it. Also, it would be nice to have the cables come out of the top too, where it lays flat. That's another thing to look at too. So we got to look at that and see. So we got that. We're going to get our offset probably like a 0.1 all the time on offset. A 0.1 for offset. Yeah. So we hit that right there. Get us an offset. We'll stick that to a 0.1. Wow, got that. So right now we're good. We can extrude this out and we will have the outer shell pretty much already done. But what we want to do is we want to make sure lengthwise that we're going to have enough, and then when we get ready to put our spring in action, I thought about using um like the screws, like having the terminals on the end of the wires, and then having screws on the actual battery case where you can put the cable on and screw it down, but on the other side of the nut, um you can it'll just be making contact with the batteries. So I think that's how I'm gonna end up doing it. The spring is gonna be at the bottom on both sides. So for positive and negative in the bottom, there'll be like a wire plate, right? Like a flat plate like this. And then I'll have the springs on both sides. So once we push into it, maybe maybe I can do, or maybe I can do a slide, right? I don't know. That's something I have to look at and see. Cause I mean, I don't want to think about it too hard, cause you know how that go. When you think about things too hard, then you start to make mistakes, or you don't get nothing done. And we want to get some stuff done, right? The whole goal here is to get some stuff done. But I do want to play around with that idea of having the screws come out of one side where we can screw into we can screw our terminals, you know what I'm saying? Like we can hook our terminals onto the screws. That would be dope. Which could easily be done. Easily. We can do it on the M5 screws. Have the M5 screws making contact with the batteries. Yeah. Yes. I think that's how I want to do it. And also I was thinking about maybe I can make this into a S3 battery pack rather than a S2, how I had it just now. And this is just thinking about the future of what I want to do with this. Because I know eventually this is gonna become a hopper and not just be a dancer. So if I want to keep up with that idea, my battery is gonna have to go into the direction of being an 11.1 volt, you know what I'm saying, or a 12 volt um, battery pack. So in that sense, having a S3 might not be too bad, it might not be a bad idea. But we just gotta go and see see what happens, you know what I'm saying? That's the best I can do is I just gotta start designing somewhere. So once the design starts, let's see, we gotta get our overall here. We're at 0, and this is just for one battery, 2.664. So 2.664, right? 2.664 times 2. Or 665. I could have just went 665. Or I could have just went 2.67, you know. But that times 2, 5.3. So 5.33 is what we'll say. And this doesn't have to be accurate because we're gonna have those springs in there to make up the difference anyway. Man, this thing running away from me. Come back. All right, so we're gonna extrude this. Finish that out. Extrude that. This is just going to be the dimensions of the two batteries together. So we want to make that 5 inches and 33. So this is to represent what two of these batteries stacked together would be. Okay. This is the outer case of two batteries. So the idea is to maybe take this S2 into a S3. So we'll be dealing with like a triangle type ordeal. Once we get this figured out. This is a really it's an all right design in my mind. The way I'm thinking of it in my mind, it's gonna be pretty cool. But all right, enough talking about that. What we're gonna do is take we gotta get the diameter of this so we can cut it in half and run it. Or middle way. I'm just thinking of a way to create the triangle point. It's got to be the same diameter as this 0.93, right? So 0.93, but I kind of feel like we can do that based off of a circle as well. So let's see. Let's draw it up. So from there, we can do a point reference. Point 0.93. So if we go 0.93, right? 0.93. We can rotate everything based off of this. Or we can do a pattern. So we can do a pattern, circular pattern, select that, and then our axis would be this thing here, creating 3 of them, and they overlap a little bit. So we got to make that circle a little bigger. I was trying to take the easy way out, but it wouldn't give me the easy way. But also, that wouldn't be a bad idea too, though. Yeah, that might not be a bad idea. Let's rock with it. All right, let's rock with it. This is compact enough. Yeah. So we'll do it like this. We'll take the sketch out. We'll select these areas where they overlap each other. All right. All of those bodies. Let's get I'm trying to think of how I want to do this. Because I want to select those bodies, right? And it's going to create an inner groove on the walls, but what we can do is cut those out. So I think that's the direction that I really want to go with it. I wasn't thinking about that center point being the point. Here, let's do this. Because we'll complicate it, right? It'll be complicated if we go that route. It don't have to be that complicated, you know. It just has to be functional. And we're not trying to really cut any corners. So, I mean, we can take this thing up to a 1 inch, right? We could just do a 1 inch because we have the space. We have the space. Okay. So we got that. Let's bring this back in and let's try it again. All right. We're going to roll out, create a circular pattern, select our body, select our axis down there. And that's a lot better for what it's worth. We don't have to do no cutting work. We got everything right where we need it to be. The center part right here, I'm thinking we put a over cap in there, and then what is that? Um, we put a screw in there. We put a heat press in there, and get screws in there and get that thing looking right. You know what I'm saying? Get them right. Let's see. All right, so we're gonna get these bodies, tie them in, right? Make them one. Get that one piece now. Also, we want to take these and we want to make something with it, right? So I'm thinking, if we go with an M5, our whole dimension is gonna be whole dimension. Will be 0.7. So that's a 2.4. So let's see a 2.45, right? 2.45 will go in with that on a larger scale. 2.45. And I don't mind taking the screw out, you know, if that's the route that I go with this, having the cap on it, on the batteries, just secure it with some sort of screw on top, and that would be dope. That would be dope. So, what we say, was it 2.7 or what? 2.45 or 0.25, 0.245. I'll be all off sometimes, y'all. Y'all gotta bear with me. Let me know if I say something wrong too, because I be mispronouncing stuff. But people just be letting me talk. They don't stop me. If I mispronounce something, then let me know. All right, so now we at that 0.245. So let's take the center line. Take the center line, and that center line is gonna be at 1. And that's how we're gonna get to where we're getting. That guarantees that we're gonna get, or break it in half. I'm sorry, we're gonna break it in half. It's gonna be a 0.05 or 0.5, right? 0.5 is half of that circle that we just created to make this whole loop thing happen. Why does it feel wrong though? It feels wrong. It doesn't feel right. It looks like it's off slightly. But you know, we're gonna keep it going. Yeah, I think it is off. Oh, it looked off, but it's not off. See what I'm saying? I deal with this a lot. I be like in my mind struggling with some of the dimensions, especially in the software, because of how the grid lines kind of throws your eye off. It gives like some sort of optical illusion, and you start second guessing your measurements because it doesn't look right on the screen. And then you end up miscalculating. So we had a 0.245 for this circle, which is pretty big. So in theory, that's gonna eat into that will eat into um the space for where the batteries are gonna go and possibly make it tight. So M5 might be overkill too. Um, and we won't really with this the screw we want at least. So we can go M4. We can go M4. We still, but you know, we don't need the screw to be as big as an M5. Sometimes it just feels like going bigger is better. 0.195, we can try that. 0.195, 195. Yeah, see, that's more reasonable. That'll give us a little space in between that meat. You know what I'm saying? We want that. We want that space to, so that when we press these in, that plastic doesn't melt and deform the side and cause an issue with the batteries being able to slide in there easy. That's what we want. If the batteries don't slide in there easy, we fail. We failed the mission. So M4 we're gonna go with, which is still gonna be good. So we'll complete that right there. Come on, be nice to me. Oh, my CPU is coming tomorrow too. I cannot wait for my CPU to come in so I can run this platform without, you know, having these hiccups and freezes and stuff. This thing is just it'll be doing its own thing, especially when I go live. I'm trying to show everybody what I'm working on and be active with everybody, but sometimes we get stuff like that where it just crash on me. Like that's unfortunate, but you know, we'll bring it back up and see if it puts us back in the loop where we were at. But if not, I mean, we wasn't that far along, and I still know what the measurements are. So that's the beauty of it, is that we know what the dimensions are. Let me check the chat. What's up, bro? Um, the LGs. Yeah, so when I chose these batteries, these were based on a flashlight I'm building. I'm still working on this flashlight. Um, but these batteries was for the flashlight. And then uh no, so the batteries is not for a plasma cutter. I'm actually building the battery pack for this RC car, Lowrider edition that I've been creating. And I wanted to clean up I'm just cleaning up parts and making them my own, so it'll all be a part of a package that people can download and put together themselves. But the goal is to make it affordable to where people could purchase the little parts and things to do this whole project, you know, and not have to worry about coming out of pocket too much. So these rechargeable batteries is one of them. I got this as a bundle deal, and actually it's very hard to purchase batteries in Hawaii because they won't ship it to Hawaii. And so I found this pack of 12 and it was affordable for me, and I was able to get it, you know. So I ordered them, and they came out, and it was good. I got a whole lot of action going on over here with this live stream and whatever's going on with my computer right now. It's like it's lagging or something. And then the software is taking its time coming up. All right, let's get back into the battery thing. But no, so these batteries were just me working with what I had already. Once I started doing this car build, I didn't have batteries. For the reason that I was telling you about, that, you know, companies wouldn't send those batteries overseas like that. So I set out to make my own battery, and these were able to be shipped. So that was the plus for me. And then the greatest part about these batteries is the discharge on these is a 5,000, you know, which is like really awesome to have that type of rating on a battery, you know. 5,000, nice. These hold the charge really nice. But to have 3 of them in series is gonna be really awesome. So now I'm just building a case for them. We got, let's say a 0.4. We'll make these go in a 0.4. Extrude negative 0.4 on that side. Nice little hole. And then we'll get that. Well, let's save this. Since they did give it to us, I'm glad they gave it to us and we was able to do that. I gotta put this where I can see the chat. All right. Let me see. All right, let's redo our fusion. Fusion on the battery pack side. All right, there we go. We are back. All right. So we have that there. I'm gonna select that shape again. We went down 0.4. So we're gonna extrude past that now. Okay. So we're gonna take this and the inner side. We're gonna extrude that downward. We're gonna do a two-sided extrude. One side is going to be -4, and then the other side It's gonna go down farther than that. And we did it this way because we have already cut the hole for the other side. So this side is gonna just be solid.